All right, our next speaker is coming to us from the United States Military Academy at West Point. Dr. James Starling is an associate professor and also director for the Center for Data Analytics and Statistics at West Point. Thank you.
Okay, good. All right, good afternoon. Let me start this here. I'm Jim Starling. As mentioned, I'm at West Point. This is not really my work. I'm just kind of a senior advisor in this case here. We have a major hobbyist, Data. He was around here earlier and last night, if you may have seen him. And really highlighting the work that we have of the two cadets, Max Felter and Charlie Wheaton. That hopefully you got to see their posters last night. They did some really cool work. I'll try to dig in a little more. If you have any questions, if I can't answer it, I'll probably give you their email and you can ping them. But anyway, so here's kind of the background and kind of why we care about this. So right now, a couple miles from here, we have DevCom is working on this advanced targeting lethality aided system, Atlas. That little pod basically sits on top of a tank, Abrams or a Bradley or some sort of vehicle that has a weapon system. And basically it has if you're sitting inside the turret there or wherever you're sitting, you'll see something like this where it basically pops up with targets. And what it does is basically it's scanning and it picks up targets and it'll pass it off to essentially the shooter or the tank commander that's in there. So this is kind of the application we're looking at. This area is kind of from a ground one. I'll show you, we kind of looked at it from also like UAV. If you talk to Carly Parcell, she's another one of our cadets that spoke last night. She did more of like a dismounted thing, so vehicles, but personnel too. Basically any kind of threat that we can have that's kind of on the ground for the Army. So here, we think in the future it's going to be the technology we have should be relying on AI for automation. The backbone is going to be some sort of computer vision model, we think. There's other models too, but for some of these ground-based things, some sort of computer vision. Sometimes we have thermals or night vision type of things too, but the same sort of idea. Some of the problems though too is I think Cameron mentioned earlier, basically just kind of getting that quality data that we have. It's kind of hard to get that of actual like tanks out in the open. Kind of anecdotally, I heard a story of a system the Army had built. And they went out and had a certain system, and they took all sorts of pictures of it. They went and had lunch, and they put another system out in the thing called System B. Took a lot of pictures of it, and the model did really well, but really was kind of detecting was kind of like in the morning time, you had the shadows going a certain way, and then System B was the shadows going a different way. So what we might be able to do with synthetic data here is to be able to kind of modify those effects of the battlefield too. It's expensive to kind of take multiple pictures or images of different scenarios and stuff, moving those systems. Some places you may not be able to get to, but if you set it up synthetically, you can hopefully create a lot of these images that you could use to train your models on. So another thing too is just labeled data. We do have a slight solution for that we kind of used. Dr. Bhattacharya here kind of gave us this idea, and we started it last summer, but he may have something that's even better. We found a way that works. He may have something that's even better. We'll see. So here, research question is, can we use UE5, Unreal Engine? It's a gaming engine. Anybody have kids in here? What's the big one? They parachute out at the start. I don't know the name. My cadets are gone. They would tell me. Fortnite, yes. Thank you. So Fortnite is built in Unreal Engine 5. Also is built lots of different things. Very, very realistic. Of course, that one has people with all sort of blue skin and whatever else. But a lot of people use it for like car advertisements and whatnot. But we're trying to see if we can use synthetic data to improve model performance. So we use UE5, Unreal Engine 5. We focus just on using YOLO, which is you only look once. Cameron mentioned Coco. That's another model. This is very similar. It takes a picture like you have there on the bottom right, and we'll put a bounding box around it. And kind of like it basically detects it and then classifies it, kind of all in one shot. And we're kind of going to restrict our research here to just kind of looking at like above grounds, like a UAV observer. So here's kind of our pipeline, very kind of vanilla. There's a lot that goes into it though. So there were two other cadets here. That first bullet, it looks like it's easy, but like I've never played Fortnite, and getting in the system and setting up, it's kind of a lot of work. And actually thanks to Sambit's students, they actually sent us some stuff to get us started. We actually found a cadet that was a freshman. He's on the esports team, and I'm like, hey, I have a project for you. You know anything about machine learning? He's like, no, but I can play video games. I'm like, cool, we could use you. So he actually got in there and has been making us some videos. I'll show this here in a minute. But that first bullet, it looks easy to say. It's a lot of work though. Another thing too, labeling images. With some of the work that Cameron mentioned, we had Carly Parcell did some stuff with some dismounted troops. We had those images already pre-labeled. That actually is a little bit of work to do that. So you can go out and take a bunch of videos, but then put a box around it, each individual frame. That's a lot of work, okay? Also storage, we use RoboFlow for this. This is on the low side, right? If you're going to use something secret or something that's a little more, you might need to find a different solution though than using RoboFlow. So yeah, I'll leave that to you. But and then the last thing is of course to train the model. So okay, so here this is really hard to see, but here's kind of the videos that we came up with at first. You see a nice soccer field there with 3 tanks. The upper right, you have 3 tanks out in the snow. It's hard to see down on the bottom left, but there are 3 tanks in that picture as well in a wooded area. And then we have 3 tanks in the desert. Those are kind of a little bit easier to see. They're kind of mixed up in the trees there. But this is what we passed along to the model. We made these videos, labeled them. How do we label them too? This right here is called CVAT. I forget what it stands for, but essentially it allows you to kind of take a video and it looks at a frame, and you can, there's an interpolation model, or interpolation mode, I guess, where you can put a box around the tank, and then a few frames later put another box, and then it works perfectly if it works better if your camera's still. This one's kind of moving around, but basically it like interpolates where that box is. Okay, so you put a box here. I go a couple frames later, and then I put another box, and then like those intermediate frames, it like puts a box there, kind of like interpolating between it. If you just like, old school, anybody do stats back in the day, you interpolate between things in the back of the book. Yeah, remember that, the stat stuff? So it kind of does that in 2 dimensions with a box too. So pretty cool. This is kind of the one takeaway. If you're having trouble labeling stuff, this is one way to do it. This one, I think it was on the web. You might be able to download something to get it working, because I think there is a GitHub thing that you can host it on your own, so you're not pushing the data somewhere if you have some secret stuff or something that's on the high side. So we also found a real data set to kind of do our testing. So we found this on roboflow.com as well. The cadets went out and found 20,000 labeled images of tanks. They went through somehow and picked 600 of them. I guess they found 600 that were more like a UAV standpoint. And went with those to kind of like basically see how well is our model doing with real stuff, okay? And also training as well. So here's, again, kind of using those 4 videos we had. If you look at the upper right, that 0.67, that was our accuracy for using just the real data. And the upper right there, that blue box there, the light blue, 0.64, that was our accuracy for bringing synthetic data in there. That's not that good, right? It actually dropped. It actually went down a little bit here too, which is, we're kind of scratching our head. I think part of it has to do with the fact, let's see, is it going here? Yep. I'll bring all this up here. So part of it, we only have those four environments, right? So, I mean, we had 4 environments. We got a lot of frames. We had thousands and thousands of pictures that we labeled using that CVAT tool. We had the boxes there that YOLO needs, but it doesn't always solve our problem. It really kind of becomes like a design of experience problem, right? So going forward, we can make more videos of that soccer field, and it's probably not going to help us, especially when we're trying to look at tanks and whatnot in Ukraine or other places that are real pictures, right? So, we got to kind of think about that smartly, and, we got that esports guy who can crank it out. However, it's still not instant, right? We can't get those bounding boxes instantly. Still takes a bit of time to get those things. So instead of going forward, we need to think about the things that we want to, environments that we want to build in UE5 and do that smartly. So, let's see. The target set, this is what I just said here. So the target set, we were looking at those real pictures there. We need to make sure that those 4 things that we had, we should have more than 4 scenarios probably. But we need to make sure they're kind of like the target set there. And then if you want a robust model, though, you also got to make sure that it has some variation as well. So next steps. So this is kind of the pipeline, is kind of what the title was. The next couple slides here, I'm going to kind of show you some stuff that shows what Charlie did first and then what Max did. So basically looking at increasing the synthetic sets, more variation, and then look at the effects of distance and viewing angle. So those 2 things in particular. So the first thing Charlie did here, look at that cool rotation there. He kind of just wanted to look, let's kind of just make it simple. And what is the effect of having a different angle of the tank, right? Because if you look at it head on, it looks different than the side. It's a different profile there. So the other thing too was, the distance. And we did, they did, units in UE world. I don't know what that translation is to the, real life. You have to look at like focal angles and all that stuff with cameras and whatnot to figure that out. Probably find a physicist to help you out there. But you can basically look at the different distance that we have there and kind of to see what happens there. So we saw here, if, upper left, basically the 1,500 and kind of going out further away. We saw that our average, 2,500 units, whatever that is in actual distance, we're not sure. But going out, that's kind of where it stayed about, 85% accuracy. I'm sorry, this is IOU, which I'll explain here in a minute. But then it drops off. So the IOU is intersection over union. So we're using YOLO, which uses a bounding box. So if you think like a Venn diagram, right? I have like the Venn diagrams. And what you want is to like your bounding box that is true, that you've said you've validated. You want your predicted one to be like exactly over that, okay? So ideally you want it to be 1, okay, on average. Across multiple pictures there. If it's kind of missing or off, right, if it's not covering completely, well, that'll go down. So that's all it is, IOU. We saw here too, IOU for different angles. You see starting at 0, going up to 90 and 180. That's what Charlie found here. So looks like, the oblique ones are head on, and then the 30, 180, seem to do the best. Really not much difference still compared to the distance. And I forget what's, I think this right here was showing the angles. I think it was at all distances too, kind of aggregated there. Let me see. Okay. All right, another thing too, this is what Matt kind of moving into Max's work. He basically was looking at a model called Stable Diffusion, which produces synthetic images. So kind of like if you use ChatGPT 4, you can say, hey, give me an image or whatever, Dolly will give you images here. So use a different model called Stable Diffusion. So it's a little different. Maybe, just maybe. Basically, one of the ChatGPT said, hey, give me a bunch of prompts, okay? Give me a bunch of prompts, and then basically pass those to the Stable Diffusion model to get pictures. What do those things look like? Well, here's some actual examples here. And on my screen, it looks really cool. Probably not as cool up here on the screen, but pretty good, huh? So he actually, I think he passed 1,000 pictures, and he manually went through and said, those aren't good. He ended up with 400, though. It kind of matched what we passed with the real data that we're looking at. So, not too bad. And basically he's basically comparing it. So he used just an AI set here, using only those Stable Diffusion models, and kind of compared that with the image that we had done for the Unreal Engine 5 as well, and kind of compared them. You see here in the upper right, you see at least with the validation set. So when you pass it to these models, you can specify a validation set. So as it's going, it'll train, and then it kind of uses some of the data out, and it'll kind of check it to see how accurate it is. This is mean average precision. Yep. So you see here the one with the AI set actually did better. Although when we checked it with the test set, the AI one here actually did slightly worse than the one with the Unity Unreal Engine. So. All right. So in summary, the pipeline we have is pretty standard. I think you can always find ways to make it more efficient. It'd be really great to automate it. Like, hey, go to Unreal Engine and set it up for me, and then spit it out, and then label it for me. That'd be really cool. Although that part there is really manual still. CVAT helps a little bit, although it's not a panacea. There's still some time that it takes to get that. Although that did help us a little bit. At least got us a lot more pictures. Although you still need to kind of think about variety in your settings. And I think more variety would help make our models more robust. And then the Stable Diffusion thing that Max did, kind of it might be a neat, might be some potential there, something like that. Almost using these synthetic pictures to help train your models as well. So, all right, with that, that's all I have. If there's any questions.
So a question kind of pertaining to the educational experiences that the cadets are getting out of this. It's a great talk, by the way, and it's really fun to see how much this field has evolved in the last 5 years. But when you're working with the cadets, what are kind of the key takeaways that you're giving them, given that you're doing all of this at West Point with open source tooling for what they're going to need to understand when they actually commission?
Good. Yeah, I think Charlie's going to be an infantry officer. No, he's going to be a cyber officer, so he'll be on the keyboard. I think Max wants to be an infantry officer, so he probably won't use this at all. So he might use the results of this, though, right, if he's in a Bradley or something like that. As far as them getting out, I think the biggest thing was just the confidence in them taking something that's kind of unstructured. That's probably the biggest thing. So we have some cadets that you give them a problem, and they're really good at doing, they're doing their regular math classes. There's a start. We have lesson 1 through 40, and the lesson objectives are very clear, and they crush it. And then they get to a problem where like, come up with your own question. They're like, I don't know what to ask. I'm like, tell me the question, and I'll give you an answer. And so I think that's probably the biggest thing is the ones that have done well have done that part well, is where they've taken a question, taken ownership of it, and then, like for Max, for example, when I work with him, I don't have to really give him much guidance because he's kind of like, he just kind of does it and knows what to do next. And I kind of help shape what he's doing. So that answer that, I think, yeah. I think for those also, so this was pretty cool. As Cameron mentioned, took him 2 weeks. Max, I'd actually done an independent study with him last year. We kind of got a little more into the like neural networks too, which you kind of need to understand to do the CNNs kind of properly, I think. But you could really be up and running with a model. 2 weeks is probably a long time, actually. You could probably have it done in a day or two, honestly, if you know Python. If you know Python, maybe. If you don't know Python, maybe a little bit longer. So, yeah. Yep.
I've had contractors try to sell me something very similar with Microsoft Flight Simulator.
Really?
I'm just curious, did you try to train your model with completely synthetic data and compare that in performance?
Yeah, I mean, so, yeah, we did not. Or actually, we did, let's see, this one. Let's see, this one here, yeah, we did not do synthetic alone and then test with real. Yeah, that could be something we could look into. Here, yeah, basically it was layering real plus the other things too. So, yeah, we did not.
And in the image recognition, what did it consider each frame individually, or did it try to do any kind of, say, integration over time?
Yeah, that's the thing that that's a neat problem, right? So all these all the results we're seeing here is like static images, right? If you were here last night, talked to Carly with the dismounts. This is something we've discussed too. Is like, hey, if I look at a picture or a picture frame, an image kind of by itself, there's no context where it's like, I could say, hey, there's a tank here, but like if the image before it and the frame after it, right? If there's like all of a sudden you go along, no tank, all of a sudden tank, and then no tank. You need to somehow take that into account and not send like an alarm up because you had like one frame out of like 1,000 saying there was a tank there, right? Over a couple seconds. That's something that'd be cool to look at, I think, because almost like the cognitive thing too. One of these things is it's kind of like the next step is also then bringing in the human and being like, hey, there's a bad guy here. Or there's something that's going to try to kill you here. At what point do you say, what threshold is it where there's, your algorithm's detecting something, and then I need to draw your attention to that so you can action on it, right? So that's kind of the next step. Yeah, that's a good problem though. Yeah, have you figured it out? Mr. in the purple shirt? No?
Probably time just for one more question.
Okay.
So the Stable Diffusion image generation appears to be pretty inspired by movies and that kind of a thing. And so I'm just thinking one way that maybe you could augment this is by fine-tuning the Stable Diffusion model on real, databases for tanks, and then, or even using Unreal Engine. You can fine-tune it. And then I really wonder how much that would improve the performance of it compared to just Unreal Engine.
We have those 20,000 tank images that are labeled. We could get rid of the labels and just say, this is what tanks look like, I guess, right? So, yeah. Yeah, that's interesting. Thank you. Good. Sam, do you have any closing things? I know he's going to try to kick me off. Did you figure out the labeling thing?
You mean on the generated data?
Yeah.
That's the hard part.
Yeah.
How to generate automatic and cheap labels out of the generated AI, because generated AI does not come with the labels, right? Yeah. So if we can figure that out, now that's an interesting problem.
Yeah. Cool.
Right?
Things at scale remains a problem for this community, right?
Yes.
All right.
All right. Thank you.
Let's thank our speaker.